Hi, 8th grade. Welcome to lesson 2-4, equations with no solutions or infinitely many solutions. By the end of the lesson, I want you to be able to say, I can determine the number of solutions an equation has. For it, the great Carlo called twins Jasmine and James onto the stage. Jasmine, multiply your age by 3 and add 6. Then multiply this sum by 2. James, multiply your age by 2 and add 4. Then multiply this sum by 3. I predict you will both get the same number. Write expressions to represent the great Carlo's instructions to each twin. Well, we don't know what their age is, so we're going to say let A equal age. And we agree that both of them are the same age because they're twins. So we're going to say A for both of them. So he tells Jasmine first to multiply her age by 3. So that's going to give me 3A. And then he says, then add 6. So 3A plus 6. Then multiply this sum by 2. So we're going to multiply this whole thing by 2. James, so that was Jasmine's. James, multiply your age by 2. So 2A. And add 4. Then multiply this sum by 3. So those are two expressions, one for each twin. Choose 4 whole numbers for the twins' age and test each expression. Make a table to show the numbers you tried and the results. So we've got Jasmine and James. So we have their two expressions. And we're going to try their ages at, let's see, if they were 1 year old. Let's try their age if they were 3, 4, and 5. So we're going to plug in for Jasmine and James. For Jasmine, so it would be 3 times 1 is 3. Plus 6 is 9, times 2 gives me 18. James, 2 times 1 is 2, plus 4 is 6, times 3 is also 18. All right, now let's plug in 3. 3 times 3 is 9, plus 6 is 15, times 2 is 30. 2 times 3 is 6, plus 4 is 10. 10 times 3 is also 30. Now let's try 4. 3 times 4 is 12, plus 6 is 18, times 2 is 36. 2 times 4 is 8, plus 4 is 12, times 3 is also 36. Last but not least, 5 times 3 is 15, plus 6 is 21. 21 times 2 is 42. 2 times 5 is 10. Plus 4 is 14. 14 times 3 is 42. So the great math magician, Carlo, was right. What do you notice about your results? All the sums, or all the answers were the same. Okay. It's going to be true for all values. I'm not going to spend our time doing it, but I'm going to show you why it's true for all values. So if we take Jasmine's, it was 2 times 3A plus 6, and apply what we learned last lesson with distributing. 2 times 3 is 6A. 2 times 6 is 12. Then if we take James's, he had 3 times 2A plus 4, and we also distribute. 3 times 2 is 6A, 3 times 4 is 12. These are equivalent expressions. So no matter what we put in for A, we will get the same answer out. Excuse me. Example 1. For what values of x will the rectangle and triangle have the same perimeter? Remember, perimeter means to add up all the sides. So if this side is x, this side is also x. If this side is 2x plus 3, so is the other. So we want to figure out when will they have the same perimeter. So we have to find their perimeters first. That's what they did here. 2x plus 3 plus 2x plus 3 plus x. Combine like terms. So we have 2x, 2x, x, and x, 2, 4, 5, 6x, and 3 plus 3, which gives me a positive 6. Then we have the perimeter of the triangle. Combine like terms, 2x, 2x, and 2x gives me 6x, and positive 2, positive 2, positive 2 gives me 6. Solving for x, we want the x's on one side, so we're going to subtract 6 from both sides. Well, 6x minus 6 cancels out, and 6x minus 6 also cancels out. So the answer is 6f equals 6. Since that is always true, there are going to be infinitely many solutions. So if you ever have a number equal to a number, and it's true, there are going to be infinite solutions. Let's try it. How many solutions does the equation 3x plus 15 equals 2x plus 10 plus x plus 5? Well, you have to notice what we have to do on the left-hand side first. We have a 2x and an x. So if we combine those together, we have 3 x's. Then we have a 10 and a 5. Combine those together, we have 15. Solving for x, we are going to subtract 3x from both sides. And what ends up happening is the 3x's cancel out, and we're left with 15 equals 15. There's a number equal to a number. This is always true. If it's always true, that means there are infinite solutions. If the value of x is negative, will the equation still be true? Explain. Yes, it is true for all values of x. Example number 2. Anna and Lee played soccer for the same number of hours one week. How many hours did Lee play on Sunday? So what we're going to do is look at Anna's and Lee's. So in the morning, Anna, we don't know how many she played, but we know she played X every morning. And in the evening, she played 1.2 every evening. So we're going to add up. This is the same. These are the same. X plus 1.2, X plus 1.2, X plus 1.2, X plus 1.2. So there are 4 of those. That's why we did 4 times X plus 1.2. Then we add up Lee's hours. He had X plus 2.5 plus 2X plus 4.5. That's what we got over here. So we're going to do 2 things. We're first going to distribute. 4 times X gives me 4X. 4 times 1.2 gives me 4.8. Then on the left-hand side, we're going to combine like terms. I have an X and a 2X, which gives me 3X. And then I have a positive 2.5 plus 4.5, which gives me 7. Now, I'm going to solve for X, so I'm going to subtract 3X from both sides. So either subtract 3X or 4X. So subtract 3X, those cancel out, and 4X minus 3X gives me 1X. Next, to get X by itself, we're going to subtract the 4.8. So that cancels out over here and left with 2.2. So Lee played soccer for 2.2 hours on Sunday. Since X equals a number, that is the only answer it could ever be. So there's only one solution. Example number 3. Solve an equation with no solution. Gil makes 3 bracelets, and Mika makes 2 bracelets. They both use the same number of string colors. How many colors should they use to make the same amount of money? Write an equation to represent this situation, then solve. Okay, so let X equal the number of string colors. So Gil's bracelets are $5 and $2 for every string color. So you do 2X plus 5. And we're multiplying that by 3 because it says that she makes 3 bracelets. Same thing with Mika. we're going to do 3x because it's $3 for every string color plus the $3 for bracelet. And we know she makes 2. So we're going to distribute. 3 times 2x is 6x. 3 times 5 is 15. Distribute the 2. It gives me 6x plus 6. So now solving for x, I'm going to subtract 6x from both sides. They cancel out on both sides, and we get 15 equals 6. But 15 does not equal 6. So if you ever have a number that does not equal the same number, there is no solution. Let's try it. How many solutions does the equation 4x plus 8 equals 0.1x plus 3 plus 3.9x have? Explain. First thing we got to do, combine like terms. So you get 4x plus 8 equals 0.1x plus 3.9x equals 4x plus 3. Solve for x. I'm going to subtract 4x from both sides. They cancel out, and I'm left with 8. These cancel out, and I'm left with 8 equals 3. Is that true? No, it's never true. That means there is no solution. On the next page, example number 4. Determine the number of solutions by inspection, meaning we're not going to solve, we're just going to look at it. So how can you determine the number of solutions each equation has without solving? On the left-hand side, we're going to combine like terms. So I can combine the 3 and the 7, so I get x plus 10. Combine like terms on the right-hand side, 2x minus x gives me x. Well, if I look at this, x plus 10 and x minus 10, we've got the x's are the same, but 110 is positive and 110 is negative. So since they're not the same, there's no solution. For b, if we distributed 3, we would get 3x plus 12 equals 3x plus 12. We've got 3x and 3x, that matches. Positive 12 and positive 12, that matches. They're the exact same thing, so it's infinitely many solutions. Last, 5x plus 8 equals 2x minus 1. We could subtract 2x from both sides. 5x minus 2x equals 3x, and we could subtract 8 from both sides. Negative 1 minus 8 equals negative 9. So 3x equals negative 9. That means we're going to get a number for x. So there is one solution. So I want you to try A, B, and C on your own and press play when you're ready to go over it. So I'm looking here, I'm going to subtract 2.5x from both sides. So I get 0.5x plus 1.5 equals 4.7. Subtract 1.5 from both sides, and we get 0.5x equals 3.2. So I'm going to get an answer for this. So there is one solution, but I'm only going to get one answer. Now B, I'm going to distribute the 3. 3 times x is 3x. 3 times 2 is positive 6. 3x minus 6. I've got a 3x and a 3x. Those match. But then I have a positive 6 and a negative 6. Those do not match, so they're not equal to each other. There is no solution. Last but not least, C. 9x minus 4 equals, I'm going to combine like terms. 5x and a 4x gives me 9x minus 4. Looky here, the 9x and the 9x match, and the negative 4 and the negative 4 match. So they are the exact same thing, meaning it's always going to be true, meaning we have infinite solutions. All right, 8th grade, let's say it. I can determine the number of solutions an equation has. Have a great day.